Hello everyone, welcome to Aakruthi, Art of Mathematics, Simple Mathematics Classes. I am Sudhir MK. In this class, I am going to discuss competitive questions from statistics, and this is competitive task 2. Please subscribe this channel, also like and share this video. Here we see some properties of standard deviation and variance. So adding or subtracting a positive number from each observation does not affect the standard deviation or variance. That is, when we add or subtract any number from the given data, so then standard deviation and variance does not change. The next property, when each observation is multiplied by k, then standard deviation is multiplied by k and variance is multiplied by k square. That is, standard deviation of new data will be k times the previous standard deviation and new variance will be k square times the previous variance. So therefore, when each observation is multiplied by k, then standard deviation is multiplied by k and variance is multiplied by k square. So we see some problems related to these properties. It is problem number 17. Already we discussed 16 question in previous class. So now it is question number 17. A set of n values x1, x2, x3 up to xn has standard deviation sigma. The standard deviation of the n values, that is x1 plus k, x2 plus k up to xn plus k will be. So here we added k to each observation and we have to calculate new standard deviation. So that is, we know that if each observation is increased by a constant k, then standard deviation will not change. So that is, standard deviation of new data and previous data will be same. So therefore, we get same standard deviation, which is option A. So here standard deviation will not change. So standard deviation of new data is also sigma only. So which is option A. So next question, question number 18. So let A, B, C, D and E be observation with mean m and standard deviation S. Standard deviation of the observation A plus k, B plus k, C plus k, D plus k, E plus k is. Now here also each observation is added by k. So when we add or subtract any number, the standard deviation will not change. So therefore, adding or subtracting a positive number of each observation does not affect the standard deviation. Therefore, standard deviation remains same. So which is S only. So therefore, here we get standard deviation is S only. So which is option A. So it is correct option is option A. That is, standard deviation remains same. So next question, question number 19. So let x1, x2, x3, x4, x5 be the observation with mean m and standard deviation S. The standard deviation of the observation kx1, kx2, kx3, kx4, kx5 is. So here each observation is multiplied by k, and we know that if each observation is multiplied by constant k, then standard deviation of resulting observation is k times the original value. So here original standard deviation is S. Then we have to multiply k to this. So we get k into S. So which is option C. That is, standard deviation of kx1, kx2, kx3, etc. is k into S, which is option C. So next question, question number 20. Let x1, x2, xn be an observation and let wi equal to lxi plus k. That is, you have to multiply each element with l and we have to add k. So we get wi equal to lxi plus k, where I equal to 1 to n, where l and k are constant. If the mean of xi is 48 and the standard deviation is 12, the mean of wi is 55 and standard deviation of wi is 15, then the value of l and k should be. So you have to calculate l and k value. Now here it is given standard deviation of wi's. So standard deviation of wi is equal to L into standard deviation of xi's. So since each xi is multiplied by L and added k, when we multiply given number with L, standard deviation is also multiplied by L. When we add or subtract any constant, then standard deviation remains the same. Therefore here we have to multiply standard deviation with L. Therefore we get standard deviation of W series is L into standard deviation of X series. So therefore, when we substitute this value, we get 15 equal to 12 into L. So therefore, L equal to 15 by 12, which is 1.25. So here it is given standard deviation of W is 15 and standard deviation of X series is 12. So we substitute this. So we get L equal to 15 by 12, which is 1.25. Then we have W series, it is LXI plus K. So we take means, that is mean of W series is L into x1 plus x2 plus x3 up to xn plus n into k divided by n. So when we add all these terms, so here L is common, we get L into x1 plus x2 plus x3 up to xn, and here when we add kn times, we get kn divided by n. That is mean of W series is L into x1 plus x2 plus up to xn plus nk divided by n. So when we divide this, so we get mean of xi series, which is 48 into L as it is, and here n get cancelled, we get k only, and it is given mean of wi series is 55. So therefore we get 55 equal to 48L plus k. We substitute L value is 1.25. Therefore we get k equal to 55 minus 48 into 1.25, which is 55 minus 60, and answer is minus 5. So therefore we get k value is minus 5 and L value is 1.25. So which is option A. So here L value is 1.25 and k value is minus 5, which is option A. So next it is variance. The square of the standard deviation is called as variance. So when we square standard deviation, we get variance. And variance is denoted by sigma square and formula is summation of x square by n minus summation of x by n whole square. For standard deviation, we have square root. For variance, it is without square root. It is summation of x square by n minus summation of x by n whole square. It is for raw data and summation of fx square by n minus summation of fx by n whole square. For group data, that is when frequency is given, we have to use this formula. It is summation of fx square divided by n minus summation of fx by n whole square. Or we can use mean also, that is summation of x minus x bar whole square divided by n, so which is variance, and variance is denoted by sigma square. So next problem number 21. The standard deviation of some temperature data in degree Celsius is 5. If the data were converted into degree Fahrenheit, then the variance would be, here it is given standard deviation of temperature in degree centigrade is 5, and we have to calculate variance when this temperature is converted into degree Fahrenheit. We have formula temperature in degree Fahrenheit is 9C divided by 5 plus 32. So therefore here data is multiplied by 9 by 5. When we multiply data by some constant, its standard deviation also changes. But when we add some number, so its standard deviation will not change. So therefore new standard deviation we have to multiply by 9 by 5. Therefore standard deviation in degree Fahrenheit is 9 by 5 into standard deviation of degree centigrade. That is data is here multiplied by 9 by 5. Therefore, we get standard deviation in degree Fahrenheit equal to 9 by 5 into 5. So here 5 get cancelled. So we get 9. That is standard deviation of degree Fahrenheit is 9. But we have to calculate variance. Variance is square of standard deviation. So we get variance in degree Fahrenheit is 9 square, which is 81. So which is option A. So here standard deviation in degree Fahrenheit is 9. So therefore variance is 81. So which is option A. So next question number 22. The following information related to a sample of size 60, that is summation of x square is 18,000 and summation of x is 960. The variance is, using this data we have to calculate variance. We have formula variance equal to summation of x square divided by n minus summation of x by n whole square. So directly we substitute all these values. So we get 18,000 divided by 60 minus 960 divided by 60 whole square. So all these values are given and n value is 60. So therefore we get 18,600 by 60 minus 960 by 60 whole square. So which is equal to 300 minus 256, which is 44. Here correct option is option D, which is 44. So here 0 0 cancel, 6 1s are 6 3s are, and here we get 300. So we get 300 minus here 0 0 cancel, and here it is 6 1s are 6 1s are, that is remaining is 36, 6 6 are. So we get 16 square. It is 256. So we get 300 minus 256, which is 44, which is option D. So therefore variance is 44, which is option D. So next question number 23. Variance of the data 2, 4, 5, 6, 8, 17 is 23.33. The variance of 4, 8, 10, 12, 16 and 34 will be. So here given data is 2, 4, 5, 6, 8, 17 and new data is 4, 8, 10, 12, 16 and 34. That is each number is multiplied by 2. So here we have to multiply each number by 2. Then we get this data. So we know that when observation is multiplied by a constant k, then variance is multiplied by k square. So here previous variance is 23.33. So therefore new variance is 23.33 into 2 square, so which is 4. So therefore we get 23.33 into 4, which is 93.32. So which is option D. So here correct option is option D. So we multiplied each data by 2. So then we have to multiply variance by 2 square, which is 93.32, which is option D. So next question number 24. Consider the first 10 positive integers. If you multiply each number by minus 1 and then add 1 to each number, then the variance of the numbers so obtained is. So here each number is multiplied by minus 1 and added 1. So here when we add or subtract, variance will not change. But when we multiply minus 1 to each observation, so then variance is also multiplied by minus 1 square. So but minus 1 square is 1 only. Therefore we get variance of new data and previous data will be same. Therefore we calculate variance of first 10 positive integers. We already calculated standard deviation, so same type we calculate variance. We have formula variance is summation of x square divided by n minus summation of x by n whole square. So here we use formula summation of n square is n into n plus 1, 2n plus 1 divided by 6, and writing divided by n as it is. And summation of x formula is n into n plus 1 divided by 2, and writing n as it is. So we get n into n plus 1 divided by 2n whole square. And here n will get cancelled, and we substitute n equal to 10. So here it is given first 10 positive integers. So we substitute n equal to 10. So we get 11 into 21 by 6 into 11 by 2 whole square, which is 77 by 2 minus 121 by 4. So when we simplify, we get 154 minus 121 by 4. So which is 33 by 4, which is 8.25. Therefore, variance of new series is also 8.25. So which is option A. Since 1 is added and it is multiplied by minus 1, we have to multiply the previous variance by minus 1 square, which is 1 only. So therefore, variance of previous data and new data is same. Therefore, variance of new data is 8.25 only, which is option A. So next it is question number 25. In an experiment with 15 observations, the result were available. So sigma x square equal to 2830 and sigma x equal to 170. One observation that 20 was found wrong and replaced by correct value 30. The correct variance is, in given data, we have one wrong entry, that is 20. Instead of 20, we have to write 30 and we have to calculate correct variance. So here it is given summation of x square is 2830, and from this we subtract 20 square and we add 30 square, that is 20 is wrong entry, and we have to subtract 20 square and we have to add 30 square, which is 3330. So same type, summation of x is 170. From this we have to subtract wrong entry, which is 20, and we have to add correct entry, it is 30. So we get 170 plus 10, it is 180. So then we calculate variance. So variance is summation of x square by n minus summation of x by n whole square, which is 3330 by 15 minus 180 by 15 whole square. So which is equal to 222 minus 144, which is 78. So which is option B. So here 20 is wrong data and correct data is 30. So first when we calculate sigma x square, we have to subtract 20 square and we have to add 30 square. So we get 3330. And when we calculate sigma x, we have to subtract 20 and we have to add 30. So correct sigma x is 180. So when we apply formula, we get variance is 78. Therefore correct variance is 78, which is option B. So next it is coefficient of variation. So it is denoted by CV, and CV is standard deviation divided by mean into 100. That is sigma by x bar into 100. So this is coefficient of variation. If two or more observation is given, which have more CV have more variation, and which have less CV have more consistent. So next we see some problems related to coefficient of variation. So it is question number 26. For a given distribution of marks, mean is 35.16 and its standard deviation is 19.76. Then the coefficient of variation is, so here directly mean and standard deviation is given. So we can calculate coefficient of variation directly. So therefore CV is standard deviation by mean into 100, which is 19.76 by 13.16 into 100. So which is option A. So here correct option is option A. It is CV is standard deviation divided by mean into 100. So which is option A. So next question, question number 27, and it is from CET 2014. If the coefficient of variation and standard deviation are 60 and 21 respectively, the arithmetic mean of distribution is, we have to calculate arithmetic mean of the distribution when CV is given. So we have formula CV equal to standard deviation divided by mean into 100. So here we have to calculate mean value. So CV value is given and standard deviation is also given. When we apply all these values, we get 60 equal to 21 divided by x bar into 100. So therefore x bar equal to 21 divided by 60 into 100. We get mean equal to 21 by 60 into 100. So we can cancel 0, 0, and here it is 3 2s and 3 7s. So we get 70 divided by 2, which is 35. So therefore mean equal to 35. So which is option D. So here correct option is option D. It is 70 by 2, which is 35. So next question, question number 28, and it is from CET 2016. The coefficient of variation of two distributions are 60 and 70. The standard deviation are 21 and 16 respectively. Then the mean is, so here it is given two distribution with CV 60 and 70 and standard deviation 21 and 16. We have to find mean. So we have formula CV equal to standard deviation divided by mean into 100. For first distribution, we have 60 equal to 21 by x1 bar into 100. So therefore we get x1 bar equal to 35. That is mean of first distribution is 35. Then we calculate mean of second distribution. So we have CV equal to standard deviation by mean into 100. So therefore we get 70 equal to 16 divided by x2 bar into 100. So therefore x2 bar, that is mean of second distribution is 22.85. That is 16 divided by 70 into 100, which is 22.85. So here mean of first distribution is 35 and mean of second distribution is 22.85. So here in option it is given separately. So therefore correct option is option B and option C. So here correct option is option B and option C. That is mean of first distribution is 35 and mean of second distribution is 22.85. So since answer is not combined, so here correct option is option B and option C. So next question, question number 29. Coefficient of variation of two distributions are 50 and 60 and their arithmetic mean are 30 and 25 respectively. So the difference between their standard deviation is. So here we have to find difference between the standard deviation of two distribution. So now first we calculate standard deviation for two distribution. We have formula CV equal to standard deviation by mean into 100. For first distribution we have 50 equal to sigma 1 divided by 30 into 100. That is standard deviation is not given. Therefore sigma 1, that is standard deviation, equal to 50 into 30 divided by 100. That is 50 ones are 52s are. It is 2 ones are 2 15s are. So therefore we get sigma 1 equal to 15. Then we calculate standard deviation for second distribution. That is CV equal to SD by mean into 100. When we substitute all these values, we get 60 equal to sigma 2 divided by 25 into 100. Here 25 ones are 25 fours are, and here it is 4 ones are 4 15s are. So we get sigma 2 equal to 15. Standard deviation of first distribution is 15 and standard deviation of second distribution is also 15. And here question is to find difference of their standard deviation. So which is 15 minus 15. Answer is 0, which is option A. So here we get standard deviation is 15 and their difference is 0. So which is option A. So next question number 30. Coefficient of variation of three distribution A, B and C are 6.95, 7.89 and 9.81 respectively. The distribution with more consistent is. So here CV is given. We have to identify which distribution have more consistent. When CV is more, it has more variance, and when CV is less, then it has more consistent. So here CV of A is less, so therefore it has more consistent. Since distribution A has less CV, it has more consistent. So therefore here correct option is option A. That is distribution A has more consistent. So since its CV is less, it has more consistent. So which is option A. So here correct option is option A. So that's all in this video. I will continue this chapter explanation in next video. Thank you for watching. Please like, share and subscribe the channel for more video notification. Subscribe my YouTube channel Aakruthi Mathematics Classes. Thank you once again.